What's up, peers, and welcome to the World Crypto Network, here for a very interesting episode today, talking about, first and foremost, the Bitcoin Core hardware wallet interface. That is a Bitcoin hardware interface in Python and a library command line tool for interacting with hardware wallets. It has provided a standard way for software to work with hardware wallets without needing to implement device-specific drivers. Python software can use the provided library, and the software in other languages can execute the HWI tool. So this is a great little piece of software, and we will go over all the details and nuances here today on the World Crypto Network. We are joining us here today for the very first time. Andrew Chow, how are you doing?
Great, good to be here.
Very nice. We also have Nopara, the developer of Wasabi Wallet, Adam Fiskor. What's up?
Hi, guys.
And we have Rudolfo, NVK, the creator of a bunch of cool stuff, OpenDime, ColdCard Wallet, and the Block Clock. What's up?
Hello.
And last but definitely not least, we have Stepan Snigirev from Crypto Advanced, working on a really cool hardware wallet. How are you doing, my friend?
Great, and I'm glad to be here again.
Well, yes. You three, Adam, Rudolfo, and Stepan, you're all recurring guests to the World Crypto Network, so we won't much introduce you. But Andrew, this is your first time today on the WCN. So a bit maybe about your background. How did you get to Bitcoin, and what keeps you here? Why are you so motivated to get work done?
Yeah, so I started in Bitcoin like several years ago, probably 2013, 2014. And I was still in high school at the time, and it was just an interesting, cool piece of tech that my friends showed to me. Of course, not having much money as a high schooler, I was looking at the technology and how it all worked. And eventually I learned about all the code and stuff and started contributing to Core. And yeah, it's pretty much how I got to where I am today.
Yes, very nice. And of course, thank you for contributing back here to Core and making sure that we advance this beautiful piece of software step by step. So of course, today's topic is the hardware wallet integration and how this can be used with not just Bitcoin Core, but with other software wallets in general. So maybe going back to the status quo, how is the hardware wallet ecosystem before, and how is the software side of hardware wallets managed so far? Rudolfo, why would you start here?
Oh, can you hear me? Yeah. So there's been, some interesting wallets that have been around forever. I mean, as you know, we used to run a Bitcoin multi-sig server-side wallet, and we closed that service, and we decided to, we were looking for where to keep the coins, and it didn't really like the available solutions. And we weren't sure if we wanted to be in that business, and we wanted to kind of just make it sort of, if we're going to do it, it's open source and stuff. And Peter bumped into Andrew's BIP 174 PSBT, and we were like, okay, well, I mean, if we don't, because we never wanted to make apps or computer wallets, right? It's completely no interest in doing that. There is clever people doing that, and just wanted to interrupt. And this BIP really solved the problem, right? Which is hardware wallets should not be known to the computer or phone wallet, right? I mean, this two things should be completely separated. And with a partially signed Bitcoin transaction schema, you can sort of do that in a standard way. And hopefully all the hardware wallets will support it, and all the Bitcoin wallets will support it, and then, happy dance. You can go full paranoid, and you can sort of have multi-sig, and you can sort of like have, 3 different manufacturers of hardware wallets. You can have multiple software wallets. Nobody knows each other in a proper cypherpunk way. Life is beautiful now. So that's sort of like where we're at. So then we created the ColdCard. And with PSBT, you go in your desktop wallet, you create your Bitcoin transaction, right? And you save it unsigned to a micro SD card, or you use now the hardware wallet interface, and you send it to your hardware wallet, and then in your hardware wallet, you sign the transaction, right? You take it out, and then you broadcast it. This is huge for the average person, and I mean even the seasoned, to be able to do that in a sane way. I think I'm starting to now encroach into I think talking about the hardware wallet interface. So I think maybe the creator should talk about it.
Sorry, maybe I can add a few things just quickly. So the thing is that before the PSBT, so Anders, thanks a lot for creating it. I mean, it is really awesome. The problem was that all the software and hardware wallets were using something different. For example, Electron partially signed transaction format is pretty nice, but it is also missing a few features such that you can't really determine which of the output is your change output. And so you can't calculate, well, can't display everything on the hardware wallet properly. And PSBT solves like all of the problems that I saw. So hopefully it will evolve and get better.
Yes, okay, very nice. And so Rodolfo and Stepan, of course, working on the hardware side of things. Okay, Rodolfo, what's up?
Oh yeah, I mean that's the whole point, right? I mean, creating a new standard to take care of all the other standards. But this one, what's really nice about this one is that when Andrew created this, Andrew, did you actually create the BIP, or you just partook in the BIP? I can't remember. You created the BIP, right?
Yeah, I made this like 2 years ago.
Yes.
And I mean, the whole purpose of it was to get Core to support hardware wallets. That was the intent of BIP 174 originally.
And it's been sitting there for like at least 2 years, right? What was nice was when we saw that, we started contacting Andrew and a few other people, and we're like, okay, let's get this thing out, and we started sort of poking the nest and like see if we can get this out. And I think what was nice is that it was mostly good consensus between everybody. So we were 90% there, a few more changes, and this thing is out. So pretty happy about that.
Yeah, very nice. And of course, we have Adam here mainly as a software developer. So Adam, what was your experience before PSBT and before the HWI with working with hardware wallets?
Oh, I was extremely lucky with the timing of a hardware wallet integration into Wasabi because, how should I say? Okay, with the story. I was in the Advancing Bitcoin conference in London, and Tom Weiss was asking who has never used a hardware wallet before in his life. And my hand was the only one who went to the air. I never used the hardware wallet because I'm traveling around, so I cannot have any physical possession because everything gets stolen once in a while. So I cannot use hardware wallet. I just encrypt the things and send it to myself in email. So, and anyway, I started Bitcoining in 2013, where we were using blockchain info, and that was just fine. Anyway, so my point is that I was very inexperienced in hardware wallet, and I was not planning to integrate hardware wallets into Wasabi at all, at least at first. But then I realized, wow, people really are using hardware wallets, and it's like almost everyone. So something has to be done. But I was still not planning because it's a lot of work, and I tried to look into it. It's a lot of work. And then Rodolfo told me that he's sending me a ColdCard, and I told him, don't send me because I'm not going to integrate it. But he was just, no, I'm sending us. And, okay, whatever, just send me. So this was one of the very lucky thing that what happened to me, that he sent this to me. The other thing was that there was a guy on GitHub opened an issue. A lot of people opened issue with hardware wallet integrations, but there was a guy called Melbourne Developer who was actually doing hardware wallet integration in C#, which is Wasabi is written in, for Trezor, Keep, K, and Ledger. But that's when I realized, oh my God, there's so many dependencies needed for these hardware wallets, and this is a huge security risk, and I'm just not going to do it. But I was looking at alternatives and what can I do, and then I found Andrew Chow's library, HVI, which is what Bitcoin Core is going to use, or hopefully is going to use, to integrate their own library. And actually, Andrew, as far as I understand, he stripped out all the code, all the parts from the dependencies, those are not needed, and reviewed everything. And I know Andrew from somewhere before, and so I can trust him. so I was okay. Let's look at this library. How is it? And it turns out he built a unified interface for all hardware wallets. So if I write this thing once to one hardware wallet, then it's gonna work on every hardware wallet. This is the theory, but so it works like that. Let's say. Anyway, so it was one day I integrated ColdCard in 1 day with his library, and I'm like, wow, this is crazy. This is just so good. Like, oh my God. And third very, very lucky thing is that, well, first is that Rodolfo sent me the ColdCard so I can use something to integrate it with. The second is that the HBI library is a quite new thing, like half a year old, the first release. So that's ready. And the other thing is that PSBT has just been implemented by a, oh my God, I don't remember his name, a Japanese guy, to end Bitcoin, which we are using in Wasabi. That's our only dependencies now. There is Tor and the hardware wallet integration. So that's the third very, very lucky thing, that he just implemented PSBT a couple of months ago. So everything was there. I just had to drop the pieces and put it together and put it into Wasabi. I can't believe how lucky I was with this thing.
Very nice. So clearly there was a major problem before hardware wallet interface, in the sense that all these hardware wallets did not speak the same protocol. There was no standard, so we needed another standard. That's always the solution. And Andrew, clearly you had some really cool design decisions. And maybe could you please go a bit more into the details of those, and why did you decide to build HWI as you did?
Yeah, so the reason HWI is a standalone is really because in Bitcoin Core, we didn't want to have to include all this vendor-specific dependencies and code, like if Trezor do this one thing, if Ledger do this other thing. And we just didn't want to do that. It would bloat the code base and add a bunch of extra dependencies not everyone would need. And so the plan was then we would make something else that would have all the drivers for all the various hardware wallets, and Core would just call that thing and it would do all the work speaking to the hardware wallets. And that was HWI. But the other problem was then, how do we get our transaction information to this other software? And at the time I started working on this, that didn't exist. And so I made PSBT to fulfill that need. And of course, since it was going to be Core calling HWI to do the work, HWI had to have exactly the same interface for every device, because Core wouldn't know, or Core shouldn't have to distinguish between the devices to pass all the info to HWI. So that's how that's why we came up with having this single unified interface in theory. There has been a few problems because of user interaction requirements for the Trezor, but yeah. And there were a couple other design decisions I made a bit more recently, and that was like that was mostly removing a ton of dependencies. and instead of depending on the vendor provided library like TresorLib or the CKCC protocol, instead of depending on those, I actually pulled the source code and just dropped it into HWI and then cut out parts that were unnecessary, such as in Trezor. Previously, the default thing for Trezor was to call back to Trezor's servers to get previous transaction information. And because all of that was provided by a PSBT, HWI doesn't need that. And so we just remove that and cut out this entire dependency that was completely unnecessary. And there have been also a lot of other code in these libraries related to altcoins that we don't need. So those got cut too.
Very smart decision. Rodolfo, what are your thoughts on all this?
Yeah, I mean, we had to remove PyCoin from CKCC protocol, which is, honestly, it's great. I mean, every dependency when you're dealing with the stuff is an attack vector, right? I mean, it's just one more thing that somebody has to audit, right? It's a massive problem. So what's truly beautiful about all this stuff is that sort of like a few tenets of security get the check mark, right? The software doesn't know what the hardware is, so it doesn't, it's less attack vector there. The hardware can be fully disconnected from the device, from the computer, and so you can have real air gapping, and you have a standard. I mean, for everything. I really love this idea. I think this is sort of, was really well done.
Okay, yeah, very nice. And of course, you said that we wanted to integrate all the hardware wallets that already exist today, like Trezor and Ledger, right? But then, Stepan, you're working here on a new hardware wallet. How did you, as a new entrepreneur entering this market, take into account that now this type of standard exists?
Well, with PSBT, it is extremely easy, actually. So I'm working on my prototype now, and all this do-it-yourself hardware wallet stuff. And basically today I spent a few hours to integrate it into with HVI and with Bitcoin Core, and it was extremely easy. As soon as your hardware wallet supports PSBT, you don't need to do much to talk to Bitcoin Core. And one thing that I would really love to see in the later stages, that more software wallets support PSBT as well. Because right now, having PSBT on the hardware wallet, on Bitcoin Core, and having HWI library in between, well, we have a pretty nice compatibility with these pieces. But if we want to integrate with other software wallets, it would be also nice if we could use HWI for that.
I believe Samurai Wallet already supports PSBT. I'm not sure if they do it via HWI. It might be their own sort of implementation, how you get the files out, I can't remember. And Wasabi, we had to write a plugin for Electrum, hopefully. But isn't Electrum now supporting PSBT natively, or no?
No, they still use their own transaction format, and there you're really still missing a few fields that are already in PSBT. So ideally, they would better just switch to PSBT, but they never stick to the standards. So Electrum uses their own transaction format. They use their own mnemonic format, so with the checksum stuff. So yeah, they are pretty old software, so they also have their own standards.
Yeah, I mean, they're opinionated. Implementation, which kind of makes sense. But yeah, I think that can be solved with the plugin architecture there.
Very, very quick question. By supporting PSBT, do you mean like the code is supporting PSBT and passing it to the hardware wallet through the code through USB, or you are specifically talking about PSBT by putting it to a SD card and then messing with the hardware wallet, coming back with the signed PSBT with the SD card? So which one are you talking about?
So they kind of, once you implement the standard in the wallet, right? So say say Samurai implements PSBT standard in how they create unsigned transactions. The other mile of pushing the stuff to the wallet, either via the micro SD or via USB, that's the easy part. And even for wallets that have very opinionated ways about how they want to do their USB stuff, they can create their own plugins. But what's more important is that we're all talking about the same Bitcoin standard for unsigned transactions, right? Like if that stuff is sorted out, then the rest is easy.
Okay, then just a very quick clarification. For the next release, you plug in your hardware wallet with USB, click load, and you are inside the hardware wallet, and you can do stuff, but you cannot coin join. Okay, and after that release, you will be able to do the thing by hand, right? So putting it to SD card, I never tried that workflow, but I mean, we are implementing it right now, but not for this release, just quick clarification.
Yeah, so I'm a believer that there's sort of like two sort of stages of hardware wallet, and that's why people need to have sort of like more than one, right? You're always going to have sort of like a warm solution and a cold solution, right? And the cold solution, you sort of don't want anything to ever touch a computer, right? That's why I like the microSD stuff. Now, for your warm stuff, maybe that's you making money on join markets, or you doing coin join. So for that solution, the USB sort of like is more convenient. But if the software wallet does the job right, it could batch a ton of PSBTs, right, into the micro SD, and then you can just take that at the end of the day, plug it in, and sort of sign all those transactions and then get them out. So through batching, you can still sort of like respect that the idea of really keeping things there gapped.
By the way, coming back to the coin join and other things. So recently there was a discussion in the Trezor issue about coin join and PSBT, and it looks like we need some extra fields into PSBT. And so I have questions to Andre. So what do you think about the future of PSBT, and what other key value pairs are you planning to put there? So for example, maybe for coin join or for Lightning Network support, or some other functionalities beyond the simple pay-to-address stuff?
Well, I mean, PSBT has all these fields, so it can be extended by anyone. And one of the things I've been thinking about has been this coin join proof thing, which would be another field. Although how the proof would actually work is still debatable, because I think that is a kind of a hard problem. But one thing that I've been discussing with other people is like sort of either like vendor specific fields or experimental fields. So like maybe defining like the top, if you have any field that's greater than OXF0 would be like experimental, and then you can just define whatever field you want without really having to worry about taking something that someone else might be using. And also like the same idea with like vendor specific fields, like you would have like another set of bits be reserved for like vendors can just define whatever the hell they want and to use within their own ecosystem, but not like for public use.
That makes sense, right? Because maybe some wallet's going to support, say, PGP or something. You can start using the same architecture, like the same single protocol spec that you have there to sign whatever you want. I mean, messages, it's just pretty easy.
Well, the only thing that in PSBT there have to be a raw unsigned transaction in the Bitcoin format in the first field. So, well, I think that PSBT should be only dedicated to Bitcoin stuff. So maybe some complicated stuff, either vendor specific or application specific, but not PGP and messages.
I mean, I personally want to use it just for Bitcoin, but knowing how the space works, right? If we don't provide some sort of space for people to do stuff, like that they want to do it, they're going to end up creating a whole new protocol spec, and then we're all screwed again.
Well, with another fields on like non-Bitcoin applications, we can just replace the magic and still use the same serialization format. For example, for PGP, you can just use instead of PSBT the prefix of PGP and then FFFF.
And there's actually already been a new field added, not by me, but I think for one of the like proof of funds or signed message BIPs, someone has already added another field for PSBT to include some like message information or something.
But it is still not in the BIP, right?
No, it's in the BIP, or maybe. But the I mean, generally, it's not like for the BIP process. I just have to act, and I'll probably do it if it's like not ridiculously stupid. And just generally, anyone can write their own BIP, send a post to the Bitcoin Dev mailing list if it's still up, and define a new field for whatever they really want.
So there should be probably some changes in PSBT for Schnorr when we have Schnorr, right? For example, for music and other stuff.
Yeah, there will be more fields for that.
Okay, Adam, you wanted to jump in here as well, and I imagine talk a bit more about coin joins and PSBTs.
Yes, I wanted to, and touch Schnorr too. So right now, we are giving back the unsigned transaction to the clients from the Wasabi coordinator. And the client sign it and then give it back. Now, it turns out that the unsigned transaction is already huge, and the signing phase because of this takes some time. Now, if we do PSBT, which is basically the exact same transaction, plus a bunch of other fields, then it becomes even bigger. Okay, then because we are doing it over Tor, right? And Tor sucks in terms of reliability and speed. Anyway, but we can do it. Let's do PSBT. Okay, now add Schnorr signatures in the picture. And then with Schnorr signatures, you have to give out first to one peer. The peer has to sign, give back the signature. And then you have to... Oh, no. You can just pass around the signature. You don't have to mess with the whole transaction. So what I wanted to say does not was stupid. So yeah, we can go on.
You know, a funny thing is, for example, you know, on the original firmware, we sort of thought that you could sign somewhat complex transactions, right? Because there's a limit of like sort of like memory and capacity in a specific device like this. We actually we hit the ceiling, right? Some people trying to do some transactions with a lot of inputs and outputs. So we have optimized a lot. The firmware is not out yet. I think Peter has pushed in the dev branch. I can't remember. Anyways, now you can do, I think, 20 or 30 inputs, but you know, as the transaction sort of complexity goes up, we might have to figure out a way of optimizing some of this stuff by the computer, right? Because, you know, there's just so much juice in embedded devices if we want to keep them safe.
It's okay. You force Wasabi users not to merge too many inputs together. It's good.
Well, actually, PSBT is can be parsed in a stream, so you don't need to store all that inside your hardware wallet, right? So for legacy transactions, for instance, you can just verify it and keep only the output, or just and with the SegWit transactions, it is also very nicely streamable. Like you have a cache of different parts of the transaction for signing. So, well, I didn't try to sign 20, 30 input outputs, but yeah, there is a way to optimize it.
Yeah, we're dealing with very limited hardware on our end.
Yeah, one of the first comments I got about PSBT was that it's not terribly space efficient, and I will admit space efficiency was not near the top of my list of priorities because I wasn't really expecting PSBT to actually end up on devices. It was more intended to be the thing that goes between the two pieces of software and not the thing that ends up on a device.
Yeah, we have 500.
Do
12.
not try to optimize PSBT for space because it's really nice and simple right now, and if you start to tweak around, then you're just gonna make sure no one ever really gets that far to really understand what the hell is this thing is going to do.
You know, we have
That was partially why I pushed back on the protobuf suggestion, because protobuf has its own like extra complexity with shrinking things, and I didn't feel like learning about it either.
No need. Who suggested it? Mike Hearn?
The Trezor people suggested it because they use protobuf in all of their for their communication protocol between the software and the Trezor.
Yeah, but again, it's an extra dependency again, so, and not justified, I think.
Yeah, you can just HID. It's all there. There really isn't much you need to make, you know. Yeah, I mean, the space is going to get interesting. I think we're going to reach a limit, right? Like we have 512 kilobytes of FBI flash. So that's it. We're doing writing, rewriting so that we can sort of fit more in. But there is just so much that can be done. I mean, I don't know. Maybe at some point, if people really want to do a lot of complex transactions, maybe we start writing to the microSD first, and then go back and then rewrite, and go back and then rewrite, and then go back and then rewrite. But it gets pretty tricky very fast.
One thing is that like the PSBTs can end up ridiculously large because of having non-SegWit inputs, and you know those are full transactions and they're big. One suggestion I got from Greg Maxwell was like have kind of a trusted-ish field where you say this is a trusted non-SegWit input, and you just give it the UTXO, which would be totally unsafe if you did not trust the computer that you are working on, which is why it's called a trusted input. So that would reduce the size by cutting out all of the things, all of the transaction things that you don't care about in the input. And that's also why the SegWit outputs are much better, because they're tiny.
Well, as I said, I think that keeping legacy transactions in the PSBT is not a big problem, because what you do on the hardware side, you just start hashing as you get this legacy transaction. You hash until the end, and at the same time you look at the output that you are looking for, and just store only the output and verify the hash. And it's you can even have it with 10 kilobytes of memory. Oh, well, I mean, with really tiny memory on the microcontroller. You don't need to load the full PSBT at once.
Or let's just increase the block size.
Well, that's if you're streaming it, right? I mean, if you're trying to do this, you know,
from SD card, you can also read from the file as a stream. It is the same. Like in Linux, everything is a stream. Like everything is a file. One question I have about the kind of future plan with hardware wallets. So the multi-signature on Bitcoin Core. So right now we have a very nice workflow that is described in this HVI repository documentation, how to set everything up if you are using a single hardware device. So like you import 1000 keys into your Bitcoin Core and everything works nicely. But if you want, let's say, to use Bitcoin Core with a 2 of 3 multi-signature with 3 different hardware wallets, and as far as I understand, in Bitcoin Core, you can't import many multi-signature addresses, or can you?
Well, you can import them, but you can't like get them as new receiving addresses. And the multi-sig workflow in Bitcoin Core is kind of not fun to use. But we are working on that. It is a major wallet overhaul to switch it to something that's much more friendly to multi-sig and like generally arbitrary script pub keys. And part of that is going to be the output descriptors and mini script stuff that SIPA has been working on.
So basically, there will be like a descriptor similar to what we have what we use right now, but with a certain script encoded there, and maybe multiple master public keys, right?
Yeah, something like that.
That's cool.
Yeah, okay, very nice. So maybe touching on that, what you just brought up, the output descriptors. What exactly are these about, and how can they be integrated or used in conjunction with the HWI and PSBT? Andrew.
So output descriptors describe outputs. They describe basically the set of conditions that you need to spend an output, which is what an output script is, but in a human readable form, and using an output descriptors combined with mini script can be converted directly into that output script. And so something that can parse an output descriptor now knows all of the conditions that are necessary to build the final transaction or build the final input that spends a particular output. So I don't think descriptors will be part of PSBT, and that's because mini script is a direct one from a descriptor to a script. So if you have a script that it's under the definitions of mini script, you can convert that into a descriptor and then know the conditions that you need to spend. So with PSBT as it is now,
We lost you there, Andrew. The microphone.
We cannot hear you, Andrew.
Oh. Can you hear me?
Yes.
You can?
Yes.
Okay. Yeah, so the wait, what was I talking about again?
The output descriptors describe the outputs.
Did it cut out that early? Oh.
No, not that early. Sometimes later. Just kidding.
Well, so with output descriptors and mini script, because mini script is a subset of script, you can convert a mini script into a descriptor, and so there isn't a need in PSBT to include output descriptors. But like the software like HWI could maybe not HWI.
We lost
The
you.
NSA is at work again, Andrew.
Have you tried
it's
plugging
too
it
important.
out and in again? That works 60% of the time, every time. But yeah, Stepan, maybe can you go a bit more into how a hardware wallet might use these as output descriptors?
Actually, hardware wallet don't need to know anything about hardware descriptors, only maybe to generate one well, even though it is not necessary. So basically, if you have the output descriptor, this is the part of the well, this thing should be used in the software side. So basically, it explains the watch on the software wallet, how to derive the keys and what exactly to look, well, for what outputs to look in the blockchain. So basically, these descriptors help your software wallet to understand how much money you have. And then when the software wallet finds the particular output that fits to the descriptor, then you can convert it into PSBT and send this PSBT to the hardware wallet. And then hardware wallet can sign. So the only thing from our side, from the hardware side, we need to care about is to parse and to verify the PSBT. But on the software side, I think this output descriptors and miniscript can do pretty much the same as what PSBT can do for hardware wallets. So it's just an awesome and unified way to describe how software wallets should search for output and monitor the money on the blockchain that you own.
So traditionally, it's been a problem, right? Every different wallet does multi-sig differently, and all these scripts, as wallets go away, get messed up and they're not properly documented, and then you cannot redeem your coins if you don't know where to look for them and how to sign them. It's a problem. I mean, look at what was it, that wallet from way back? I think it was Copay. Just I think like they changed names, and then they changed how they did things, and then you simply kind of got screwed if you don't have a copy of the software back then. And then there's also like you need to describe the order of the signers too, right? It's like who is the master signer, and that stuff. It's a mess, and it's the kind of mess that like it's not. It's very unintuitive on how to go figure out. So if you lost like the original implementation and you're trying to figure out how to sign something from some old backup, or you could spend a month and still maybe funds are not safe anymore. It's gone.
Yeah, so for example, what we have right now that is commonly used in software wallets is this XPub, YPub, ZPub, right? So for the legacy, for SegWit and SegWit nested in the script hash. And yeah, Trezor invented that and use it, and many other wallets use this style, but this is very limited to only the standard ways, right? So to pay into a particular script. And what we would have instead with these descriptors is you can describe arbitrary scripts that you are using. So for example, you are using time locks or something. Then you can describe it in this descriptor, and then you don't need to switch between these different master public keys. You just always use XPub or TPub for testnet. Yeah, so I think that it is a very nice way to use it, and I would personally really like to see that as a BIP. So I don't know if there is a BIP about descriptors or only Bitcoin Core implemented, but having a BIP like this for software for watch-only wallets would be nice.
Yeah, just another standard for it to get argued about.
Well, as soon as you have a standard that comes from, that goes into the BIP and that comes from Bitcoin Core, and our unified reference implementations use that, then it becomes a really standard.
Yep.
Okay, Adam, so you developing a software wallet, what are your thoughts on these output descriptors?
I'm not quite sure how I could use it for anything, so no, I don't have any thoughts.
Well, for example, if someone wants to use CoinJoin together with by using at the same time multi-signature. So right now you have only a single HD key and that's it. But what if people will, after complaining about hardware wallets, they will start complaining about multi-signature with hardware wallets, and then something more complicated to watch blockchain.
But the problem with that is that if we start using different things, that fingerprints are users, so just not a good idea. It's like everything that can fingerprint the users. It's really crazy.
You're still muted, Andrew.
Yeah, I think it's your wire. So somehow, sometimes it works, sometimes it doesn't.
Still not there. Is it the NSA again?
let's so until Andrew tries to fix it, just a couple of examples of fingerprinting. For example, if we would expose multiple Tor endpoints, which we might actually need because Tor is unreliable, and it turns out if we would expose multiple Tor endpoints, that would be good. Then some people would communicate through this Tor endpoint, some people would communicate through this Tor endpoint, so their anonymity set would be cut in half, right? This half and this half. Very similar things are happening when you are doing things with, I don't know, like multi-signature, or you are always sending to this kind of script, this kind of address. Yeah, there is a fundamental issue between tension between privacy and scriptability, usability of something. So that's really interesting there too. So try, Andrew.
That makes sense, actually. Yeah, so for CoinJoin, you probably want a unified type of script.
Andrew, you're still out.
Do you maybe have a built-in microphone in your laptop computer? Then you can
I switched
just
mics. Does that work?
Oh, yeah, now we can hear you.
Okay.
Did you try to turn it off and turn it on again?
Yes.
And it
I
didn't
did.
work? Impossible.
Yeah. So in Bitcoin Core, we're planning on using descriptors for the wallet itself, the wallet file itself. So everything that the wallet generates would be tied to a descriptor, and then we just store the descriptor in the wallet file. And this is a pretty big architectural change, but we're going to be using descriptors for that. And this helps with importing and exporting. So you can export a descriptor that contains everything that the wallet you're going to import it to needs to know. And yeah. And then we're also going to probably be using Miniscript for the signings part, because if a descriptor, I guess I'll also be using descriptors, but by having descriptors in the wallet, you allow people to have arbitrary scripts, and in order to sign that, you would need to have the descriptor or have Miniscript in order to know what the input is going to look like at the end. Right now, what we have is a pattern matcher, and it basically just looks for, like, is this script pub key have a op check sig at the end of it? And okay, that's probably, like, does it have op hash 160 and opt up and op check sig? All right, that's a pay to pub key hash. We can sign it. But if it's anything else, nope, sorry. So Miniscript lets us do everything else's.
Okay, so as I understand it, then these output descriptors are kind of like a nice way of doing imports and exports of complicated scripts. And so does it go, or does it replace extended public keys, or does it work in conjunction with them?
It works in conjunction with them. So you can embed an XPub inside a descriptor, because at the very root level, you're probably specifying a pub key, and that can be just a pub key, or it can be the XPub with some derivation path at the end, and then that descriptor now describes like an infinite number of possible scripts with pub keys at the specified derivation paths.
Okay, very nice. So, yeah, that's interesting.
It's not particularly useful for hardware wallets. It's because it's for creating the final input, not like actually making the signature.
And how would that be useful for interactive or communication protocols, like, for example, Lightning Network or CoinJoins?
Oops. I don't think it's useful for those.
It's not. Yeah, you'd be pretty specific.
Like I think you can describe the Lightning HTLC as a descriptor, but I guess it's useful for things that haven't implemented Lightning specific stuff. If they implement this, if they implement descriptors and miniscript, then they could sign that HTLC without ever knowing that it was part of Lightning or that it was an HTLC, really. And for CoinJoin, as Nopara said, like you want to have your inputs be uniform. Like they all want to look very similar. So you don't want to have these arbitrary scripts.
Guys, I gotta head out, but you guys continue. This is useful. I bet I bet like people are getting a good idea. You know, people see PSBT and HWI, they think it's a black box, and it really is a good thing. All right. Take care.
Bye-bye.
Thanks for the ColdCard.
Yeah, you're welcome. If anybody needs it, and if you're developing something, just let us know and we'll send.
Yeah, just comment it on the chat and he will just send it for free.
I mean, listen, you know, this project this is not like a money maker for us. Like we created, like Open Dime is our business. Like we created this because we needed a wallet, and you know, if all the other wallets went away, we had a wallet. So you know, it's an open source project. If people want to sort of contribute, great. You know, it's there for that. That's the story of it.
Well, and open source
I paid for
hardware
one.
means they are for free, right?
Sorry?
Open source hardware means that they are for free, right?
Yeah, exactly. We are able to. We also convince the manufacturers to also make it for free, and the factory for free. You know, that's the only thing that sucks about hardware comparing to software is that, you know, software, if you want to give it for free, you know, people can copy those bytes. Hardware, there really is no other way. You know, there is an inherent cost that unfortunately can't be solved with copy and paste.
We just have to print more Bitcoin, and then we're back in fiat la la land where stuff is for free.
That's it. We just need to change Bitcoin to have inflation, right?
Pay for development. That's awesome. Okay, Rodolfo, thank you very much for joining us here today. And Piers, of course, follow him on Twitter at NVK and buy his awesome stuff. The ColdCard, the Open Dime, the many hats, and of course the block clock. A bunch of cool stuff that you're tinkering on here, and looking forward to how you further can improve this.
All right, take care, guys.
Okay, so now then, Nopara, anything else you wanted to touch upon?
No, go ahead, Max.
Okay, so we already covered quite a bit, and I think, well, the more of a general question then, where do you guys see the future roadmap going, and especially here with the play together of Bitcoin D and Bitcoin Core as the node part, then a software, a separated software as the user interface to that, and then a hardware wallet as the key like backup or the key usage system. How do these three systems work together?
So I want to answer this, but before that, I want to ask Andrew that. So could you explain what's the status? So Bitcoin Core is going to use this library, is already using, or what's the status? What's going on?
It is probably going to be using. There is an open PR by Shores that implements using HWI in Core. But I think we will be holding off on that until we do the wallet re-architecture, because the current wallet is not particularly conducive to hardware wallet use.
Okay, so I asked it in a very selfish point because it means Bitcoin Core is gonna take its time and it's not going to be in 2 weeks. Probably not even within a year.
Probably, I would say no earlier than a year. So probably like I'm thinking 0.19 will hopefully have our new wallet stuff, which there's also an open PR for, and then 0.20 would have the hardware wallet integration. So that's at least a year from now.
Okay, so the rabbit hole guys pointed out that there is no way to use full node with a hardware wallet, and that might be one of the reasons why so few. Well, actually, we have a lot of full nodes, but that might be the reasons why people are not really using full nodes, because they cannot plug it into their hardware wallets. So okay, they can use Electrum through Electrum Personal Server and Bitcoin Core, but the configuration of that setup is just truth of 99% of the users. So it might be an opportunity for Wasabi to ship with a Bitcoin Core node, which we are actually planning to do anyway. But if we would ship with a Bitcoin Core node, then effectively Wasabi would be the easiest way to use Bitcoin Core with a hardware wallet, and that's my thinking.
Yeah, and I mean, like, the fact that I couldn't use a hardware wallet with Bitcoin Core was the whole reason I started doing all of this. Because I did try I tried the Electrum X with Bitcoin Core, with Electrum, and that was difficult to set up.
I tried to set up Electrum X actually, and I failed.
Well, because you work on Windows, of course. That was the main issue.
Actually, it's possible. It's like Bitcoin developers. I try to use their projects, and it just doesn't work on Windows. Like Wasabi is the only software that's working on Windows.
Actually, I think it is possible that hardware wallet support gets into 0.19, but I'm not an optimist, so I don't think it will.
I cannot make any predictions anymore because I thought the neutrino filters are never going to be merged, and they were just merged, and you know, like you can't predict these things.
Wait, so BIP 15758 got merged to what, the master branch, or will be coming in version 0.18? Or?
It's in the master branch, and only the one that specifies the filters. So I think that's 157. Only the block filters, so like none of the P2P stuff has been merged, and that's not going in 0.18.
Oh, okay. I would like to ask, but I don't want to sidetrack the topic. So
Please go ahead.
So what does it mean? What was merged and what wasn't merged?
The part that was merged was constructing the filters for each block, and so that is stored locally and can be used for rescanning. What was not merged, and I don't think there is a PR for this either, was the sending the filters to other peers part. So that hasn't been done yet. and it is questionable as to whether that will happen, because that's the whole SPV discussion.
Okay, so what's the point of it then? I mean, construct filters, but you don't serve it.
Construct filters and make rescan not take 20 hours.
Oh, okay. Okay, I didn't know you can use this for this.
Oh yeah, that makes sense. So you have the filter of all the blocks, and then when you have a new extended public key or new coin that you're looking for, you don't have to check the entire blocks, but you just check the filters.
Yeah, and it will be much faster because the filters are efficient and can be efficiently checked against. Like when I was switching my hardware wallet off of Electrum and into Core, I had a rescan from block 0, and basically I started it at night, and I woke up the next morning and it was probably done. My hard drive was not particularly fast, but rescanning currently takes a while, and having the block filters makes that way faster.
Okay, very cool.
Thank you.
Stepan, you were about to say something to that.
Yeah, so I just, well, I already forgot what I wanted to say before, but coming back to the topic about the future of this whole thing. How I would like to see it is that we have Bitcoin Core and Bitcoin D running more or less as a team and as a service, and then we have our hardware wallets that can talk to Bitcoin D to actually sign transactions and and store our keys. And on the other side, we have software like the GUI, like Wasabi wallet or any other kind of thing that already manages the Bitcoin daemon and presents to the user shiny interface. And if you want to make it remotely, for example, you have Bitcoin D running somewhere in the cloud and you connect it from your phone, then you should be able to do that. So in that sense, I think PSBT and descriptors are really awesome because they can standardize all this stuff, and then we can just write different small pieces of this and the setup and use it however we like. Yes, that's my hope at least, but I don't know right now. We have Electrum server running on top of Bitcoin D. Then we have hopefully soon Wasabi wallet running on Bitcoin D. But what other software wallet use it?
I know Armory uses Bitcoin D, but nobody uses Armory anymore. And actually, about Armory, Armory was one of the first projects I ever contributed to, and part of the reason why HWI is in Python was my plan was to actually integrate it into Armory, but Armory's written in Python 2, and HWI needed to be in Python 3 or be compatible with Python 2, and that didn't work out. I tried it for about 3 hours, and it just didn't work at all.
By the way, what are you planning in the future? Do you want to rewrite the HWI into C++ or something? Because Bitcoin Core uses C++, right?
Yeah. Since it'll just be a standalone binary that Bitcoin Core will call, the language doesn't matter. So I'm just going to keep it in Python for now. And that's also because most of the major vendors like Trezor and Ledger and ColdCard, they all have Python libraries. So it's easy to pull in changes from there instead of re-implementing protocols from scratch.
Okay, that makes sense actually. Yeah, and plus Python is really developer friendly. So like really reading the code of HWI and then implementing your own hardware wallet class was really easy because first it's nicely written and second it's in Python. Yeah.
You could re-implement it in C#.
No, please don't do it. Let's keep it in Python.
We hire you to re-implement it for C#.
I would have to learn C#, and unfortunately, I don't know C#.
Well, the good thing is Adam and Nicolas Turrier have literally written the book on C# in Bitcoin, so it's easy to learn it.
Yeah, it's easy to learn.
I was kind of hoping that after like the end of this May, I would be done with having to learn new languages because I'm graduating, but I don't know.
Yeah, sometimes,
Okay.
well, I mean, for me, recently I learned that I need to learn Java and Rust. Yeah, so let's keep it in Python.
Yeah, I was just kidding because Python is good because that's what hardware wallet vendors actually know, so they can contribute to your software, and I mean that's just practical. I mean, I would like to see every code in the world to be written in C#, but no, we are not living in that world yet.
Okay, yeah. So, but Andrew, you also mentioned that because PSBTs has these different fields, right? They can be tagged along, and new things can be added. So, what would that entail? Like, what stuff can we put also in there that is useful?
Well, as we mentioned earlier, like the Schnorr signature stuff and what was it? The coin join proofs and Schnorr signatures and all the like cool things that that are being worked on for the future SegWit versions. There's been some talk from some of the people at Blockstream about having liquid specific things in PSBTs, but I'm not sure if those will be public because I think they were just going to use them for like within liquid itself or something. But I mean, there's a lot of fields open and like people can suggest whatever they want, implement what they want. If there happens to be, if we run out of fields because right now it's 1 byte, we can just say, if the first byte is FF, then the next byte is really the field. So it can be extended indefinitely until someone decides it's way too large.
Also, regarding the vendor-specific things, for example, imagine that you are not even using the hardware wallets, but you are using 2 computers, an air-gapped, and you've set up a ECDSA multi-signature. So like a 2-party ECDSA where you can combine them in a much more difficult way than Schnorr, but still it is doable. And obviously it is your custom implementation, so you are using it only for yourself. So for this kind of stuff, you can also determine a new field in the PSBT that only you are using, and then pass it to the other computer that has another key, and then recombine it. So basically anything that you can think of, and maybe something that is very custom for your particular application, you can just put into PSBT.
Okay, very nice. And one other thing that came to mind, right, is that PSBT is a nice standard of communicating unsigned transactions and, of course, partially signed transactions. And the Lightning Network is a network of payment channels that work with unconfirmed but partially signed transactions. So might PSBT be useful for Lightning Network wallets and nodes?
I think it depends on what the Lightning developers decide, because basically we have standards for Lightning Network and for communication there. So we have all the bolts, and I don't remember exactly what is the network format there, but in principle, yeah, I think that. For example, when you get a commitment transaction from the other node that proves to you that you will be able to get the money from your newly opening channel, then it is a partially signed transaction. So it would make sense to use PSBT there. But I don't remember what exactly is used for communication because I'm kind of working on the other side of the problem. In principle, for Lightning would be nice, but also for Lightning Network when communicating to the hardware wallets, because you need to send to the hardware wallet not just a partially signed transaction, but also additional proofs that, for example, there was an HTLC that I got from another node, so we can already sign a new transaction where you get rid of this HTLC and just update the channels and things like that. And hopefully it will be done using PSBTs, because then hardware wallet integration of hardware wallets into Lightning Network clients would be really easy. So this is another thing that I'm working on, like how to get hardware wallets working with Lightning. And right now the problem is that all Lightning implementation are, they use some kind of dedicated signer that just blindly signs the transactions, and it doesn't have all the necessary information to actually prove that, I can sign now and I'm only gaining funds for the user. So if instead of this data that is different between different Lightning implementation, we would switch to PSBT with some extra fields, then it would be really great.
I have a question. I have a question to Andrew. So how did you come up with this creative name for the wallet, HWI? How did it happen for the library?
It happened because I thought of hardware wallets and I need to interact with them. So hardware wallet interaction.
Genius.
And PSBT came about because Peter was like, well, we have partially signed Bitcoin transactions, so PSBTX, but let's just drop the X and call it PSBT because we needed a magic four magic bytes.
Okay. Yeah.
There's an ICO for that. That would be catchy.
PSBT coin.
So the blockchain would not have any signatures, just unsigned transactions. Yeah, that seems nice.
You know, Max, that you can put the signed transaction into a PSBT too, not only unsigned ones.
Yeah, that's the tricky thing.
It's a little inefficient.
You can have unsigned, partially signed, and signed transaction in the PSBT format. So the name is completely confusing.
Yeah, I don't think PSBTs are really useful for like sending things over the network either. Like someone suggested something like using PSBT to hold PSBTs in the mempool or something like that, and I didn't see how that would actually work at all.
Well, PSBT kind of has a lot of private information, so all the scripts and witnesses and partial signatures from other parties. So you really shouldn't broadcast it to the network. So yeah.
Well, most of it ends up public anyways, except the only thing that you really don't want to broadcast is that derivation path, because that no one sees that, but like the signatures and pub keys, those will be public anyways.
Yeah, right. As soon as you see the PSBT of someone else, you know their master. Well, you don't know the master public key, the fingerprint and the derivation path, right? But then if you see another PSBT from the same person, then you see that it is the same fingerprint, so they obviously owned by the same guy.
Yeah, and that's one of the problems with coin joins, because you would be able to see, like if you were malicious on, say, Join Market, and Join Market was using PSBT, you would be able to see the same person making different coin joins. So one option with that would be to just not send the derivation paths. And part of the PSBT spec is you can you can send a pub key with a derivation path of just M. So the pub key is its own master public key, which is true. Every public key is its own master. So that would leak no information, but it wouldn't be terribly useful.
Yeah, I mean, why would you share the key path to anyone and just leave it out? Why would you share information that you don't need to share?
Yeah, so with PSBT, you normally just get rid of all the stuff that the other party doesn't need to know. So in case of CoinJoin, you don't send the derivation paths, you only send the CoinJoin proof, maybe. Yeah, nothing else.
Okay, yeah, very nice. Stepan, you also just uploaded here a little video with a demo of your new hardware wallet here that you're working on. Could you tell us a bit what is going on here?
Well, it's not my new hardware wallet. It is just a do-it-yourself hardware wallet with the developer board that you can easily buy. So basically, I already set it up and imported all the keys into the Bitcoin core. And now what I do, I just use the hardware wallet interface or interactor to send the transaction. So in this case, the hardware wallet is connected to the computer with the USB cable, and I wrote a very simple module for HWI to talk to it. And the goal of this whole thing was I just wanted to try it out how easy it is to integrate a new hardware wallet into HWI. And damn, it is very easy. I was mostly debugging the hardware part, not the software part. So like in a couple hours, you can integrate any hardware wallet if you know how to communicate to it. In my case, it was easy because I made the hardware wallets be able to do the PSBT anyway. So I just send the PSBT back and get the signed one. And yes, still, I think that it is there is a lot of work need to be done on the Bitcoin core side, especially on the Qt interface. So right now, you need to go to the command line and enter all these commands. And sometimes you screw up because it is, well, JSON encoding, decoding errors, quotes, double quotes, and all this kind of stuff. So it is not extremely user-friendly, but I think it is already getting there. So this is a huge first step to proper hardware wallet integration into Bitcoin Core. Yeah, and also right now I put there in the description of the video the source code, how I poorly implemented the integration with HWI, as well as the firmware for this developer board. And later I will probably put the whole firmware code just to let people see how to make your own hardware wallet.
On the GUI stuff, someone is working on making a better GUI. I think it's Glenn Willen. He was using Armory before, which has a pretty good GUI for doing cold wallet stuff. But since Armory is in various states of unmaintained, he's trying to make Bitcoin Core have a similar GUI that is much more user-friendly for doing cold wallet, and then that will much more easily translate into doing hardware wallet stuff. And also on the integration into HWI, I did intentionally make it very easy to integrate, since instead of having to import like each specific device driver, I made it just search and it'll pull in any files in that devices folder and import that as a new device. So the integration is supposed to be just add a new file that has the name of your device, and it'll magically work.
Yeah, so you just add the device into init.py, and then you write a few comments. I think that I wrote basically two. One, how to get a master public, well, a certain master public key from the device, given the path. And the second one is how to sign the transaction. Yeah, and then if you have these two functions, then your hardware wallet already works with Bitcoin Core. Very easy.
Wow, very, very awesome. So yeah, we covered a lot, and we're already getting late, and Stepan and Adam have to get some sleep so that they can keep coding tomorrow, and of course Andrew as well here on the other side of the lake, so much easier time zone for him. But Andrew, is there anything that we have missed? Anything that you still would like to mention?
I don't think so. Oh, I would like to mention that if you're making a hardware wallet, please don't make users interact with the computer and have to send things like pins and passphrases from the computer to the device. That's a major pain point in HWI. You might notice that Trezors have some usability problems. But yeah, otherwise I think we covered everything.
Okay, very nice. And same question to you, Adam. Anything that you still would like to bring up?
Andrew, do you want to work at Wasabi?
I'll think about it.
Awesome.
Hired on the spot. And guess what? You can actually get you can get your belt, and that'll help a lot. Keeps you motivated, and looks awesome. So that's definitely something.
Yeah, it's the Wasabi Dojo. They turn it around like a Karate Kid. Yeah, that's it. Awesome. Yeah.
Much better, much better. And the hair helps a lot. That is going to be the new style for hardcore hodlers. So Stepan, same question for you. Anything else you want to bring up?
Well, I think that we covered more or less everything, so let's just keep great work and keep developing the ecosystem. Yeah.
Yes, for sure. Thank you all. Well, 3 and 4, and now that Rudolf was left, you do awesome stuff for Bitcoin open source development, and that's really, really damn important. So, Andrew, thank you very much for contributing your time and attention and your skill to Bitcoin Core and making sure that we get all the awesome stuff here in there. Of course, including but not limited to the hardware wallet interface and the partially signed Bitcoin transactions. Adam, thank you for working on Wasabi and making sure that we get a privacy first software wallet that can then be used to interact with hardware wallets. And then Stepan, thank you for working on the awesome Lightning Network scriptable hardware secure module awesomeness that is the Crypto Advanced wallet that you're tinkering on. And of course, Rodolfo for making the one and only ColdCard, which uses like all the cutting edge features before they're actually released. So he has kind of a nasty habit of building stuff that was like ColdCard was tailor-made for PSBT long before it's officially in Bitcoin Core. So that is really nice. Piers, thank you very much for joining us here today on the World Crypto Network. And of course, also check out all the events that we will be speaking at and doing really nice, interviews with all the peers there. Lots to do. Oh my God, this year is going to be crazy. Many conferences, way too many, but good to be at these Bitcoin Tribe gatherings and make sure that we build out this ecosystem and advance it step by step. So thank you very much for joining us here on the World Crypto Network, and see you on the next show. Bye-bye.